Hello everyone, my name is Necati Kaan Aydınlı. In this video, I will present my Physics 102 project, where I measured the capacitance of a parallel plate capacitor by changing the distance between the plates using a stacked sheet of paper. Each paper layer adds a small and consistent thickness, allowing me to increase separation gradually and observe how capacitance changes. I will also show high-precision picofarad measurements taken at 1 mm and 2 mm. The capacitance of a parallel plate capacitor is given by capacitor equals the vacuum permittivity multiplied by dielectric constant multiplied by the area of each plate and divided by the separation distance between plates. The A is given us as 100 centimeters squared, and D will be our variable where we change to see how capacitance changes. K is the dielectric constant, where in paper it is 2.89, and E is the vacuum permittivity, which is also a known variable, as 8.854 multiplied by 10 to the minus 12. The key point is that the capacitance decreases as distance increases, and it follows a 1 over d relationship, meaning the curve is not linear. To perform the experiment, I created two aluminum foil plates and placed them horizontally. Instead of adjusting the distance manually, I inserted sheets of paper between the plates one by one. Each sheet has a known thickness, so adding paper layers gave me an accurate and repeatable way to control the separation. The plates were connected to a capacitor meter capable of measuring capacitance in a picofarad range. Here is a video of me trying to do the experiment. At 1 millimeter with 10 sheets of paper, the capacitance meter showed approximately 223 picofarads, and at 2 millimeter with 20 sheets of paper, the capacitance meter dropped to around 129 picofarads. This behavior clearly demonstrates the inverse relationship. Doubling the distance nearly halves the capacitance, exactly as I predicted by the theoretical formula. Here you can see the plot comparing the theoretical and experimental values. The red curve represents the theoretical 1 over d trend, while the points show the measurements I obtained from different papers' stack thicknesses. Although there are some small deviations due to surface irregularities, contact resistance, and tiny air gaps between papers, the overall trend seems to follow the expected 1 over d curve. In summary, this experiment demonstrated how capacitance decreases when the plate separation increases. Even when the distance is changed using something as simple as stacks of sheets of paper, both the plotted data and 1 mm and 2 mm precision measurements strongly support the theoretical 1 over d model. This simple setup highlights how sensitive capacitors are to small changes in distance, especially in the picofarad range.